Determine equation of the graph, and we have graph of sinusoidal functions here. I'll do a couple of them for you. Now this graph represents a sine function and we need to write equation for it. Now sine and cosine functions are similar functions with just difference in phase shift. Rest of the things are same for them. Now to model it or to write an equation for it, let's go and start with the general equation. So general equation for us is f of x is equal to a times f of which could be sine or cosine k times x minus p plus q. Now what are these constants here? A is the amplitude, which goes how much up and down the wave goes from the axis of symmetry. K is number of waves in 2 pi. P is the phase shift from where the wave starts, that is the characteristics. And Q tells us by how much the axis of symmetry moves up or down, correct? So that is the meaning of these things. And how do we find them? Now, as you know, A, the amplitude, can be found by the formula A equals to maximum minus minimum divided by 2, right? So we can find the maximum and the minimum, take the difference, divide by 2, and we get the amplitude from the wave. Now Q can be found by average. Q is the average. The symmetry, line of symmetry for this is the average, which is add maximum minimum, we do maximum plus minimum divide by 2. So that is how we find Q. And how about K? K tells us number of waves in 2 pi. So K is basically equals to 2 pi divided by time period t. If you are doing it in degrees, this is in radius, then you could use 360 degrees divided by t. So both will give you the value of K. And P is the phase shift. So we need to check the starting point. For cosine function, it should start from the maximum value, right? Going downwards. And for a sine function, it starts from the 0 value, which is on the axis, going upwards. The mean value, I should say, going upwards. So we normally just track those points by how much units have they moved left or right. That gives the value of P. Now let's really do our question. So here, what is the maximum? So maximum is this, which is 1. So we can write, so let's write down what is maximum. So we say, well, the maximum is equal to 1. How about minimum? Minimum is minus 3. Correct. So from here, we can find A and Q. So let's find that out. So A is maximum minus minimum divided by 2. So 1 minus minus 3 divided by 2. And we get A equals to 1 plus 3 is 4. 4 divided by 3 is 2. So we get A. And Q is add them divided by 2. Q is add, so 1 plus minus 3 divided by 2, which gives us minus 2 by 2. So Q is minus 1 for us. Correct. Now how about K? To find K, let us see how many divisions are there between the two maximums or two minimums. Okay, that is a good point to check. So before that, let's see the scale. Now this 2 pi is divided into 1, 2, 3, 4, 5, 6 portions, right? So we can write here that each division is 2 pi by 6. So each division here is 2 pi by 6, or which is pi by 3. So each division is pi by 3, right? So if you have to count from one maximum to the other, we get 1 pi by 3 and 2 pi by 3, correct? So that is one wave, 2 pi by 3, correct? So our time period here is 2 pi by 3. So we say time period t equals to 2 pi by 3. And therefore k will be equals to 2 pi divided by 2 pi by 3, which is equals to 3. So k is 3. Now when you find k, it's a good time to check what does it mean. K equals to 3 means that in a period of 0 to 2 pi you should have 3 waves, correct? So if you start from the origin, then do we have 3 waves? Let's start from here, the bottommost point. So going up, and 1 wave, 2 wave, 3 wave, perfect. So there are 3 waves between 0 to 2 pi, and therefore the value of k should be 3. So we could have got it direct also, right? So that is perfectly fine. So we know k equals to 3. So now to find the phase shift, let's draw our axis of symmetry, which is at -1. So here is -1. So let's draw -1. That is our axis of symmetry, okay? There we are. Now, from here we observe that going up, sine wave starts from here. Now, that's not a very good point to figure out, because this is kind of in the middle of pi by 3 and we cannot really find it very accurately, right? So in this particular case, this is a good point to start with. So we'll prefer to write this function as a cosine function, right? Now, there are 2 ways you can write this cosine function. One, you can think about saying that the phase shift is, since the top of the cosine function is 1 unit away and each unit is pi by 3, we say, well, p is pi by 3, right? And we can write it like this. So that is one way of writing this. So what I will do is I'll write this as a cosine function. Now, I've already got the values here, so let me write down my values, rest of the value, which is, I have here a equals to 2, q equals to -1, and k equals to 3. So these are my values. I need to find p, that is it. And that's my first column where I calculated all my values. Perfect. Now, to find p, if I consider this to be a cosine function, then my cosine function is starting after 1 unit, which is pi by 3. So p is pi by 3 for me. So let me write first equation for you in this form, and I'll write it here for you. F of x is equals to a is 2, and function I'm taking is cos, and then bracket. It's better to use square brackets. K is 3. Since we have this bracket also, right, then there is confusion. X minus. Since cos function starts with maximum, this maximum seems to have shifted by 1 unit. That means 1 unit right gives us p value of pi by 3. So we can use this as pi by 3, correct? Plus q. Q is -1. Oh, I wrote wrong. -1. Q is -1. See, 1 unit down. -1. So that is one equation which represents our graph. We can write this equation like this also. We can write this as, since it starts from the bottom, like a reflection from that wave. Do you understand? The cos starts from the top, this is starting from the bottom. So it's cosine reflected without any phase shift. So we could write this as -2 cos of 3x -1. Do you see that? So this is alternate way of writing the same equation, and both are correct. Now if you really have to write in sine, then it starts from here. So this point could be considered as 2/3. It is not half, right? It's kind of more than that. So, but it is an approximation. So for this particular graph, we will limit ourselves to the cosine function. But I hope you appreciate and understand the method followed here to get the equation, right? It is as simple as that. Once you get your graph, find maximum, minimum, add them, divide them by 2, get the axis of symmetry. Sketch the axis of symmetry. Then find the difference, divide by 2, get amplitude. Or once you find the axis of symmetry, you can check Now you see axisymmetry is here. You check amplitude. 1 unit and one more unit. 2 units. So amplitude is 2. Perfect. Then you can also see how many waves are there with between 0 to 2 pi. So if you start from here, 1 wave, 2 wave and 3 waves. That gives you the value of k, 3. And that's what you need, right? And you get your equation. Perfect. I hope that makes the job very simple and you understand it. Let's go through the next video. Thank you.